In my time working as an electrician out in the field, I commonly took resistance measurements for one reason or another. And each time I did, I had to ask myself two questions. The first one was, what is the resistance value I thought I might be looking for? And secondly, kind of given that, what kind of a range setting would I need if I didn't have an auto ranging meter? And to understand why I asked those questions, we'll go through that a little bit here in a moment. I'm Mitch Hagman, and today we're going to take a deep dive into resistance measurements and take a look at range settings and the impact that has when you do take a measurement. It's kind of dramatic, and it might be surprising to some of us. The very first thing I want to do is show you where we have the leads placed for our meter, and then I have a bunch of notes I want to talk about. And following that, we'll zoom into this a little bit and take some measurements and kind of see if we can improve a little bit of what I'm talking about. So the very first thing is, if you look, the black lead I have in the common port of the meter, and the red lead is over here in the volt ohm port, and that's where you always will put them. And these meters, the first thing you want to know, are not conducted on energized circuits. We are not to do this on energized circuits. The second thing is, these types of measurements are not polarity sensitive. And what I'm talking about when I mention that is, the red and the black lead placement does not matter. You could place it this way and read a circuit, or this way, and it doesn't matter because they are not polarity sensitive. The next note I have is when you make a resistance measurement, before taking the measurement, you want to test the meter for function. I won't do that now, but when we get off screen, you'll see exactly what I'm talking about. We always want to test it for function before we take our measurement. And the third note I have is an auto ranging meter will use all the ranges in the DMM profile and capture the measurement using the best range for whatever the resistance of the target measurement is. So an auto ranging meter has the advantage of going through all the profiles to select the very best one for you. If you have a manual ranging meter, you have to select your own. The next note I have is watch the prefix. When you do take a measurement, you have to watch the prefix displayed on the meter because it may show K for 1,000 ohms, or it may show M for mega ohms, or it may just show ohms for ohms, and you have to pay attention to that or you will misinterpret what the meter is telling you. And again, I will go through this on measurements and show you live what we're really talking about. And then selecting a range value, if you have a manual meter and you select a range value below the target measurement, what you'll end up with is the meter will show you get no reading, even though you have your leads placed across something you should get a measurement. You won't get one because you place the meter out of range. And again, I will show that here in a moment. And then finally, selecting a range value above the target measurement value will push the measurement off into the resolution. In other words, your meter may have a measurement, but all you'll see is zeros, or you may see 0.001 or some such, and really it's not giving you a very easy measurement to interpret. And again, I will prove what I'm saying here in just a moment when we get off screen and take some actual measurements. I am off screen now, and we'll take a look at our setup here before we take any measurements. The first thing you'll see is I have 4 resistors taped to a piece of paper, and I'm using a pencil that's actually got some chew marks from me, and I will use it as my pointer. So the very first resistor is a 47 ohm resistor. The one next to it is 150 ohms. And then beside that, I have a 10K ohm, or in other words, 10,000 ohm resistor, and then a 100K ohm, or 100,000 ohm resistor. And off to the side, I have the meter already set up. I've already turned it to ohms. And this is an auto ranging meter, and meaning that it will go through all its profile. This is capable of easily picking up 1,000,000 ohms or anything lower than that. So it should have no problem with displaying whatever we need to measure. And I had mentioned previously, one of the first things we need to do is test the meter for function before we try to pick up any measurements with this device or this instrument. So I will touch the leads together, and you can see it's showing 0.1, 0.2 ohms, so it's working fine, and it shows only ohms. Before, it was showing M, with an ohm symbol beside it, and it's also showing OL, which is out of range, meaning it was not picking up any measurement. And so when I touch it, it does pick up the measurement, and you can see it goes to to ohms, and it's 0.1 ohms. Now let's take a look at each of these resistors in auto range mode. So we'll go to the 47 ohm, and when I read across it, you can see it's 46.6, which is common. These resistors are not always 100% where they are supposed to be rated. And you can also see there's no prefix, no K or M in front of that. So it's 46.5 ohms. And 150 ohm resistor is next. And when I touch those leads, you see I now have 147.1 ohms. It's not quite 150, but it's showing, again, the ohm signal. The next one we're going to read is a 10K ohm, and we should see something different. We should see a K appear before the measurements because we're going to go to a new range setting on the meter. So when I do, you can see it's showing 9.79 K ohms. And so 9 in this case, we're looking at thousands, so it's 9,790 ohms in this case. And that's why I was mentioning before, you have to pay attention to the prefix in order to understand the measurement. And finally, we'll take a look at the 100K ohms. And when we do that, again, you see it shows K ohms, and it shows 98.8. So what it's really saying, it's 98,800 ohms. It's not quite 100,000, it's 98,000. So again, it just tells you you really have to pay attention to the prefixes. The next thing we'll do, I'm going to go off screen here for a little bit, and we're going to look at manual range settings, and you'll see what happens when we take measurements with that. What we're going to do now is manually select a range, and if you look, you can see we're in mega ohm range right now. When I want to select a range, I simply press the range select, and it'll indicate what I'm ending up with for a range. So I press it once, and I am now manually set for the highest range, which is in the mega ohms. It says 60 mega ohms, which is 60 million ohms. So with that in mind, we'll take measurements and see what happens. And what I've done effectively here is I've placed some of these resistors out of range by making that selection. So remember, we're in the mega ohm range. So if I try to read the 47 ohm resistor, we'll see what happens. But first we'll test our meter for function again. And you can see now we're showing a bunch of zeros there. It's working fine. So I go to to test the 47 ohm. And you can see it's pushed everything off into the fine resolution. It's actually giving me a measurement. It's all a bunch of zeros, but it's far off to the other side of the decimal point, and we can't see what the measurement is. Even though it is a measurement, we can't determine what it is because it's too far off into the resolution. It's pushed off into the zeros after the decimal point. So it's useless for us on that. And we'll go to the next one, the 150 ohms, and it's essentially the same thing. We're showing a bunch of zeros because the measurement's too fine a measurement for that high of a range setting. And now let's see what the 10,000 ohm resistor does. Okay, there it's showing 0.01. And that's kind of weird to interpret. You're actually looking at 10,000 ohms, but it shows as 0.1, which shows you really have to pay attention to your settings and interpretation whenever you're doing this. And finally, we'll look at the 100,000 ohm. And you can see now it's 0.1. It's just shifted the decimal point 1 point, but it's really not very helpful when trying to take a measurement. Now I'm going to go to the other extreme. I'm going to go down to the ohms setting and see what happens. So we'll hit the range button. It's going now into ohms right there. Now we're in the ohm setting, and when I test the leads again, we'll make sure everything's working okay, and we are. We're getting a measurement, so it's working fine. If I go to read the 47, you can see it's reading what it did before in auto range. It's 46.6 ohms. If I read the 150, it should pick that up. And I have 147.1. It settled on finally. But now here's what's going to happen when I go to the 10K and the 100K. I have placed the meter out of range because I've got my measurement range is too low for the measurement I am going to be reading. So I'm looking at a 10K resistor here now, and it's showing OL. It remains out of range because I have placed the meter out of range by selecting the wrong range setting. And just to show you this is still working, If I touch the leads together, you can see it is working, but I've selected the wrong range setting and it won't pick anything up. So in one direction you get a bunch of zeros, and the other it doesn't pick up anything, and it's going to be the same when I go to the 100K. And so in looking at this, you can clearly see you need to know what kind of a measurement you anticipate measuring, and then you need to make sure that you're picking the proper range to get the measurement. Thanks for watching. Please hit the thumbs up and subscribe to the channel, and check out the links we have below. Come back for new videos. We should be adding content each week. And finally, visit the Taking Measure website.